As we continue and talk about inverse relations and functions, we want to be able to, find the inverses of relations and then verify two relations are inverses by using compositions. And we'll look into that. And, so here's our vocabulary words: inverse relations, inverse functions. Two relations are inverse relations if one relation contains elements of the form AB when the other relation contains the elements in the form B of A. So it looks like the inverse relationship, if you notice, it looks like it's sort of like switching my x and y. But we'll examine that and look into it more. And then two functions, f and g, are inverse functions if and only if both of their compositions are the identity function. And we'll talk about what an identity function is as we progress. But as we look at inverse relations and inverse functions, I'm just going to say that if we have this yx, inverse functions look as if they are reflective over the line y equals x. For example, a general exponential function may look like this, and a general logarithmic function may look like this. And what we find out that, if you look at those accordingly, if I say, whoa, look at that, it looks like those two functions, granted I'm not perfect, seem to be a mirror image of each other over this y equals x. And that's sort of the characteristics that we start to see when it comes to inverse relationships. We can see that kind of effect going. It's sort of the reversing of my x and y's. So here, inverse relationships. If f and the inverse, if f and inverse f are a function of, how do you think we say that? F of -1 are inverses, then f of a equals b, if and only if f of b equals a. So they're saying that literally when I put an x into function f, I get out a b. So in my inverse, if I put a b in, I get out an a. That means they're working sort of in opposite. So here, looking at this example, if I put f of 7 in there, I get 2. Well, if I put f of 2 in there and I get out a 7, then those would be inverse functions. And that's what they're saying, is that my input and my output are reversed. Finding an inverse relationship. So the vertices of ABC can be represented by the relationship 2, 4, and of course they've graphed them 2, 4, and -3, 2, and 4, 1, and they've connected all my points, so we have this triangle. And it says find the inverse of the relationship, graph both original relations and its inverse. Okay, so they've gone ahead and done step 1 for us. They've graphed. Again, we took and we reversed these ordered pairs. And step 2, find the inverse of those points. So we end up with, by reversing, find the inverse and exchange the coordinates of the ordered pairs, we end up with 4, 2, 2, -3. So let's see here, I got 4, 2. I should have 2, -3, and then 1, 4. All right. So if we connect those vertices, that would be my inverse relationship. And I will tell you that if you look at it, it looks as if it is reflective over the line y equals x. It looks like I have a reflection of those two things. So we can sort of identify that inverse relationship by the way it looks. Okay, so that is visually. Inverse functions now. To find the inverse functions, then graph the function and its inverse. Rewrite the function. Okay, so to find the inverse, rewrite the function. So they started with f of x is 3x plus 2. It says rewrite the function as an equation relating x and y. So we basically say, hey, f of x is going to be equal to y. And we replace that. So there we go, we replaced f of x with y. And then we exchanged the x and the y variables. So we had y and x, now we have x and y. So we swapped those. And now we just go back and continue to solve for y. Inverse operations, right? How do I isolate y? I subtract 2 from both sides, subtract 2, and then I get 3y is equal to x minus 2. And in order to get rid of y by itself, I divide both sides by 3. And now I have, y is equal to x minus 2 over 3. And that is how you find the inverse. Now, once you find the inverse, it tells you to replace y with f of negative 1, which is the mathematical indication of, that is how we annotate the inverse function. So the inverse of f is f negative 1. So there you go. That's what we're looking for right there. We graph them both. So we have our original function where we started off at the y-intercept of 2, and then we did the slope and connected our lines. Now when we do the next one, the y-intercept is going to be negative 2/3, sorry, right here, about negative 2/3. And then we do the order of operations, or the slope, which is up 1 over 3, up 1 over 3, down 1, back 3. And then when we connect the lines, we again can see that we do seem to have that reflection over the line y equals x. So that is, again, being able to find the inverse. This is finding the inverse. You have 4 steps. Write the function and, replace f of x with y. Then swap x and y. Then solve for y. And then at the end, you take y and replace it with inverse f negative 1. And that will find your inverse function. So go ahead and do this check. Take a moment, and I guess I'm going to do the easy part right here. I'm going to go ahead and graph this, and I start off at y is 1, and then I have a negative 1/2 slope, which means I go down 1 and I go right 2. Or I go up 1 and left 2. So negative, down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. And this is my initial function that I am starting off with. And then we want to find the inverse. So take a moment, stop the video, see how you do. Okay, so when you see, the first thing I did, here's my function, negative 1/2 x plus 1. I rewrote it as y equals. Then I swapped the x and the y. And then I went ahead and started solving for y, so I subtracted 1 from both sides. X minus 1 is equal to negative 1/2 y. In order to get this, there's different ways you can solve this, but I'm going to multiply the entire, both sides, by negative 2, and then that way, negative 2 times negative 1/2 just becomes 1y. And then negative 2 times x minus 1, so when I did the distributive property, I have negative 2x plus 2. And I then, last step, I replaced y with inverse function, f of negative 1, the inverse function, is negative 2x plus 2. So here, when I go to graph it, and I'm going to go ahead and graph it in red, starting off at 2, and then I'm going to do the slope, and the slope is negative 2 over 1, or 2 over negative 1. So if I go down 2 over 1, down 2 over 1, or I go up 2 over 1, and now when I connect my dots, I have the equation, which again, that's my inverse function. This is the inverse function, and it does look, again, like I seem to have that mirror image going. So yeah, seems right. Now, inverse with restricted domains. Well, let's see. Watch out, inverse functions is read function inverse, f inverse, or the inverse of f. I guess I've been saying it wrong, huh? Note that the -1 is not an exponent. That was understood, but f inverse or the inverse of f. Bam, let's fix that now. We'll start doing it right. Okay, so when we find the inverse of our original function, so again, we take f of x and we replace it with y, then we swap our x's and y's. Then they moved 4 over here, so we have x minus 4 is equal to y squared plus 2y. Looks like then, you don't realize it, but they just completed the square. They went ahead and added 1 to both sides, and now you have this y2 plus 2y plus 1 is actually y plus 1 times y plus 1, or y plus 1 squared. Okay? So there we go. In order to get rid of the square, right, the exponent, we have to do the inverse operation, which would be to find the square root of it. So they found the square root of both sides. So then it became the square root plus or minus the square root of x minus 3 is equal to y plus 1. Right? And then now they subtracted 1 from both sides. So we have the f inverse, or the inverse of f, is equal to -1 plus or minus the square root of x minus 3. So this is my inverse function. If necessary, restrict the domain of the inverse so that it is a function. Okay, so let's see. Because f of s fails the horizontal test. F of x fails the horizontal test. The inverse is not a function. Find the restricted domain so that the inverse will be a function. Look at the portion of the graph that is 1-to-1 of the domain and the restriction. So they are trying to say if the domain is restricted to from -infinity to -1, from -infinity to -1, then the inverse is -1 minus the square root of x minus 3. Okay, so there are going to be some limitations on being a function. Remember the function tests. So I would say if we can focus our attention on the ability to simply find the inverse function, the function inverse, that is our major goal here. Being able to do this mathematical steps to come up with it, and then in the future possibly graph it. So interpreting inverse functions. Okay, we're going to do the same process here. It says the formula for converting a temperature in degrees Fahrenheit to degrees Celsius. The temperature is equal to 5/9 times x minus 32. Okay, so the degrees in Fahrenheit to Celsius. To find the inverse of t of x, then what would we do? We would do the same thing that we have been doing, the same actions. We took our function and replaced it with y. We exchanged our y and x variables, and then we continued to solve for y, and come to find out then that y is equal to 9x over 5 plus 32. So then the inverse is going to be 9x over 5 plus 32. This is my function inverse. And this then will convert temperatures from Celsius to Fahrenheit. We were going from Fahrenheit to Celsius, now we're going from Celsius to Fahrenheit. We just reversed our direction. And I have developed here, they gave us a function and then they gave us the inverse function. If we take those, and let's see here, I'm going to take 5/9 times x minus 32, and I'm going to replace x with this entire function. So 5 over 9 times, this is a humdinger, 9x over 5 plus 32. So minus 32, right? Had to fix that. So I replaced my x value with this entire inverse, and then I still have my minus, not 23, but 32. Goodness. And when we multiply all this out, what happens? Well, this becomes 0. So I have 5 over 9 times 9 over 5x. When I multiply that out, that becomes 45 over 45x, which is simply x. So that's how we're able to tell that those two are inverse functions, because when I do the inverse, when I multiply them together, I turn around and have the identity of x. So that would be the example of finding the identity of inverse functions. Now here, verifying inverse functions, this is this symbol, right? The f of g of x, where we take all of one function and plug it into another function in place of x. That is what allows us to find the inverse functions. So here we have h of x is equal to the square root of x plus 13, and k of x is equal to 9 minus 13 squared, and determine whether they're inverse functions. So here they did this. They said h of k of x. So they took and put k of x, the entire function here, everywhere we saw an x, and then work to solve. What I'm going to do is I'm going to do it the other way over here, because we can see that. Let's see. I guess I won't do that because they've already told us that they're not inverses. So when they plug it in, they went ahead and did the standard mathematical operations. They had to multiply this out, and they had to combine these numbers, and they came up with this. And this does not seem to be a perfect square, so they can't really do anything with that any further. And they're saying it's not an inverse, but what does an inverse look like? Well, let's try it with this one right here. So I'm going to take, let's go with f of g of x, right? So wherever I have, I'm going to take f, and I'm going to input g of x. So f of x, f of g of x is equal to this, right? So that'd be 9x plus 12 over, because I replaced that x, over 9 plus 4/3. Now when I start to simplify, I know that I have, 9 over 9x plus 12 over 9 plus 4/3. This becomes x plus 4/3 plus 4/3, which is going to be x plus 8/3. Okay, so when we did the function in a function, we did not get, two functions are inverses if and only if both of their compositions are the identity function. We need this. We needed it to be this, and it was not that, so this is not inverse functions. Let me get you an example of inverse functions. So if we look at the previous page, so that's how we're able to tell that they are inverse functions. And then here in this one, it's asking the formula for a volume of the formula for the volume of a cylinder with a height of 5 is this. Determine whether this is the inverse. So if we turn around and we take and we plug in the radius, is the radius going to be the inverse? Well, we replace radius with with its given value, and when we multiply it out, we end up with 5 over 5 cancels out, pi over pi cancels out. We end up with just v. And then if we do it the other way around, we end up with just r. So it looks like r is going to be the inverse. So r square root of v over 5 pi is the inverse of v over 5 pi r squared. So that's what we're looking for, that kind of identity. So we'll do a couple of practices and we'll see how it goes in class, and there'll be more time to answer questions as we go.